Hello everyone and welcome back. Today is another big topic, especially on the AP exam. We're talking about position, velocity, acceleration, and speed. Those of you who have been in physics either in the past or currently are, I'm sure that these words are very familiar to you. Today we're going to talk about some of the calculus applications for these. Okay, first a little vocabulary. Position is where the particle is located on the x or y axis. So we're just talking about location, where it is. And generally we use x of t to represent position, or oftentimes you'll also see s of t. So either one of those can be used for the position function. Okay, velocity is the derivative of position. So when we take the derivative of the position function, we'll get velocity. It tells us about the direction of movement. That's a huge idea, okay? Velocity tells us the direction of the movement. And that means we could be moving right versus left or up or down, okay? And so what is our notation for velocity? Well, because it starts with a v, we actually use v of t for velocity. Now, velocity we said was the derivative of the position function, so it would also be the same as x prime of t. Okay, then there's some important things about velocity. Talking about right versus left or up versus down, we need to understand that if velocity is greater than 0, then the particle is moving to the right, and that's obviously if we're talking about on the x-axis, or up if we're on the y-axis. Okay, if v of t is less than 0, if it's a negative number, then we would say it would be moving to the left on the x-axis or down on the y-axis. Okay, if we're talking about the velocity being equal to 0, so if v of t is equal to 0, then we would say that the particle is at rest or is stationary. It's not moving. So a positive velocity means moving to the right or up. Negative velocity is moving to the left or down. And a velocity of 0 is when the particle is at rest. Okay, acceleration is the derivative of velocity. So if we take the derivative of the velocity function, we'll now be talking about the acceleration function. And acceleration defines how fast the velocity is changing. So as far as notation for acceleration, we are going to use an a of t. And remember that acceleration is the derivative of velocity, so that would be the same as v prime of t. And velocity was the derivative of position, so we could also say that the acceleration would be equal to the second derivative of the position function. All right, lastly, we got to talk about speed. So speed is the absolute value of velocity. Remember that the absolute value of any number is always a positive number. So that's why we said that speed is always positive. And if you just think about that, it should be common sense to you. When you're driving in your car, the speedometer is always giving you positive numbers because speed is always a positive value. Okay, so as far as the notation, we would say that speed is the absolute value of the velocity function, so we would just write it as the absolute value of v of t. Okay, these next two ideas are huge, and you're asked a lot of questions about these. The idea of when is your particle speeding up versus slowing down. Okay, so we would say that the particle is speeding up when v of t, the velocity, and a of t, acceleration, have the same signs. So that would mean they'd both be positive or both be negative. Okay? Particle is slowing down when v of t and a of t have different signs. So obviously one would be positive and one would be negative. Okay, so if they have opposite signs, we say that it is slowing down. If they have the same sign, we're going to say that they are speeding up. So I know that's a lot of information for you to take down. All of that needs to be committed to memory. We're going to go ahead and practice some examples with all of these things now. Okay, the first example says a particle travels along the x-axis according to the position function. X of t is t cubed minus 12t squared plus 36t plus 18, where t is greater than 0. Okay, so this is telling you t, which of course stands for time, is greater than 0. And I know that we don't like using the t variable in our problems, but these problems almost always use t to stand for time, so we're going to go ahead and stick with that. All right, so when is the particle at rest is the first question. This idea of at rest. You want to always think about what is the question asking. And in this question, in this case, the question is talking about movement. Okay, so it's talking about when is it at rest would mean do we cease having movement. So anytime we're talking about a movement, we know we need the velocity. Okay, because remember we said that when the velocity is equal to 0, the particle is at rest. So I need to go ahead and take the derivative of the position function to get my velocity function. So that would just be 3t squared minus 24t plus 36. And again, we said when is it at rest, that would mean that the velocity would be equal to 0. So we're going to go ahead and set this velocity function equal to 0. And as I do that, I'm going to have to solve this, so I'm going to go ahead and start factoring. So I'm going to pull out a 3, which is obviously a GCF. And then I should be able to easily factor that into t minus 6 and t minus 2. Okay, so I get times of 6 and 2. And in fact, those are my answers, okay? The function, the particle is at rest at times t equals 2 and t equals 6. And then our justification is that is when the velocity equals 0. Okay, that's how we answer that one. Okay, the second part of this question says, when is the particle moving to the left and to the right? So again, moving is talking about movement to the left and to the right. So again, that is telling us to focus on velocity because the velocity function describes our movement. And so we already had the velocity function. We found that. So I'm just going to, rewrite that down. We said that v of t was equal to 3, t minus 6, t minus 2. And so if you want to find when it's moving to the left and to the right, we need to find our critical values, which of course we already found as 2 and 6. So I'm going to get those on my number line. And I'm going to go ahead and remember it said that t had to be greater than 0. So I'm going to put my 0 as the very furthest left number, and then I'm going to have an arrow on the right-hand side. Okay, so I'm going to go ahead and make a sign chart here, just like I did when I was doing relative min and max. But the important piece here is that whereas before I was calling this f prime and this f, now I'm going to use v of t, the velocity, is going to describe our position. Okay, so velocity is going to go on the top, that was the derivative, and the position function is going to go on the bottom. All right, because that was our original function. So we're going to just kind of do a test, a sign test. Remember, all we care about is if it's positive or negative. So if I test a number between 0 and 2, obviously 1, I would plug it in up here, all right, and I would have 1 minus 6 would be a negative times 1 minus 2 would be another negative. So negative times a negative is a positive. All right, now the position function, all right, if the velocity is positive, and if we're on the x-axis, that would mean we are moving to the right. So I'm going to go ahead and put an arrow in here that says that we're moving to the right. All right, now let's test a number between 2 and 6. So I'll go ahead and test 3. 3 minus 6 would be negative times 3 minus 2 would be positive. So that's going to be a negative answer here. And so that would mean I would move to the left. And a number bigger than 6, so 7 minus 6 is positive. 7 minus 2 is also positive, so positive times a positive is a positive, and I'm moving to the right. All right, so then I'm going to be able to make my conclusions here. I would say I'm moving to the left between 2 and 6, and that is because v of t is less than 0. I'm moving to the right between 0 and 2, and also between 6 to infinity, and that is because v of t is greater than 0 there. Okay, the third part of this question says, when is the particle speeding up and when is it slowing down? So hopefully you remember from our notes that we copied down that speeding up and slowing down has to do with comparing when velocity and acceleration are both positive, both negative, one positive, one negative in either direction. So we need to get our acceleration function. All right, so I'm just going to remind myself the velocity function before I factored it was 3t squared minus 24t plus 36. So I need that in order to find the acceleration function. Okay, so the acceleration function would be the derivative of the velocity function, so 6t minus 24. All right, and so if I want to talk about when it's speeding up or slowing down, I need a sign chart for acceleration, and I'm going to compare that with the sign chart I already made for velocity. So I need my critical values for acceleration, okay, to find out when that's equal to 0. So you'd add the 24 over and you divide by 6, you get t equals 4. All right, so if I want to go ahead and make a sign chart for acceleration, so this would be a of t, and this is x of t. All right, so we're going to start it here at 0, and we'd want to put our 4 on there, and we have an arrow. All right, so really this part shouldn't be there. Okay. So I'm just going to go ahead and test in different numbers to see what the signs are for acceleration. So if I test in a 2, 6 times 2 is 12, minus 24 is negative. Okay, and a number bigger than 4, so 5, 6 times 5 is 30, minus 24 is positive. Now notice I'm not filling anything in underneath here because acceleration does not really describe any movement for the position function, so I'm not going to put anything in down there. I'm just going to leave that blank. All right, now what I want to do is grab that velocity sign chart that I had from earlier, and I'm going to kind of line it up right underneath this one. Okay, so I have, here's my 0, but on the other one, the velocity one had critical values of 2 and 6. Okay, and if I remember correctly, it was positive, negative, positive. Okay, because this was to the right, to the left, and to the right. Okay, so if I'm looking here, I need to compare, and it helps to line them up kind of right on top of each other to be able to see when are the signs both the same or both different. Okay, so if I'm looking here, I can start at 0, and we can see that from 0 up until 2, okay, so from 0 up until 2, we have opposite signs. And then they start to be the same from 2 up until 4. They're both negative. Then at 4, my acceleration changes to positive, but my velocity is still negative. So from 4 till 6, I would say that they are opposite again. And then after 6, they both remain positive. So I can see that I start off with opposite signs, then have same, opposite, then same. Okay, so remember, when they are both the same is when they're speeding up, and when they're opposite is when they're slowing down. So I'm going to clearly make sure that I'm defining what I'm talking about. So speeding up. All right, so speeding up would be when they are both the same sign. So that happened, we said, between 2 and 4 was when they were both negative. And also after 6, so 6 to infinity. Okay, and that would be because they have same signs. All right, then I can say that the particle is slowing down. So that would be when they have opposite signs. So that would be between 0 and 2 and between 4 and 6. And again, I want to tell why that is. So I'd say opposite signs or different signs. Okay, so I'm stating, if you look at my conclusion here, I'm telling what the conclusion is, that they're speeding up, when that happens, and why that is, why I'm able to make that conclusion. So make sure you have all 3 of those parts when you make these conclusions. Okay, the last part of this question just asks for the speed of the particle at t equals 5. Okay, so this should be a really straightforward question if we remember, of course, that speed is the absolute value of the velocity. So we're going to go ahead and once again grab that velocity function. Okay, so the velocity function was v of t equals 3t squared minus 24t plus 36. But because I want the absolute value, I'm going to go ahead and say the absolute value of v of t. So, and I want it when the time is 5. So I want the absolute value of v of 5. So I'm going to go ahead and plug a 5 in here. So 3 times 5 squared minus 24 times 5 plus 36. All right, so that would be 3 times 25 there would be 75 minus 24 times 5. That's 120, and then plus 36. Okay, so let's see here. If I took the 75 and added the 36, I would get 111 minus 120. And so 111 minus 120 is clearly negative 9. So the absolute value of negative 9 is 9. So the speed, and I don't have a unit of measure here, so I would just say the speed of this particle at t equals 5 is 9. Okay, the second example we're going to do is very similar to the first one. So I'm going to go ahead and have you pause this and try each of these parts, and then we'll come back together and make sure that we have it right. So get that copied down. And then go ahead and try the first part. When is the particle at rest? Just a reminder, particle at rest, okay, we're talking about the movement. Movement indicates that we should be thinking about velocity. And if it's at rest, it's not moving to the left or to the right. It's not moving at all. It's resting, and that happens when v of t is equal to 0. So go ahead and do this first part, and then come back to me when you have an answer. Okay, so let's take a look at my work and compare it with yours. All right, so I went ahead and found the velocity function here. All right, that should have been real straightforward. Set it equal to 0, and then I had to do some tricky trinomial factoring. So I did guess and check, and I just a couple tricks. I knew that it was going to have to be 3t and t in order to multiply to 3t squared. There's lots of options for 24. But I did know that because this was plus, that both of my signs were going to be minus. So that kind of helped me out a little bit. And then I just kind of went through the different options until I got 4 and 6. Then I went ahead and t-charted and got 4/3 and 6. So t equals 4/3 and t equals 6 is my conclusion. That's my answer. And then, of course, I need a justification, and that's because velocity is equal to 0 at those times. Okay, so part B, again, let's go ahead and get that down. And this time it's asking for when is the particle moving to the left and moving to the right. So just like the first one we did, 1B. Again, we're talking about movement to the left and to the right. So we're looking at our velocity function. We want to make a sign chart and interpret our results from that. So go ahead, pause, and try it on your own. Okay, so once again, let's compare your work with mine. All right, so I have my sign chart here. First of all, I grabbed my velocity function in factored form, and I put my critical values of 4/3 and of 6 that I found from part A on my number line. Please make sure that you have v of t labeled for the top of your sign chart and x of t labeled for the bottom. Okay, and I also made sure that I stopped at 0 and then I have an arrow going on the right hand side. All right, and then I went through and I just plugged in. I plugged in a 1 because 1 is between 0 and 4/3, and I got a negative times a negative, which is a positive. Again, I'm plugging it into the velocity function. All right, then I went ahead and plugged in a number between 4/3 and 6, and it was a positive times a negative, so negative. And then I plugged in a number bigger than 6, and I got 2 positives, so it was positive. Okay, so then I was able to fill in my arrows. Whenever it was whenever the velocity is greater than 0, I know my particle is moving to the right. Whenever my velocity is less than 0, I know my particle is moving to the left. And those are the conclusions I made down here. Check your conclusions with mine. Again, make sure you have justifications as well as the answer part. All right, let's move on to the next. Okay, so this is the trickiest part of them all. When is the particle speeding up or slowing down? So remember, we have to compare the sign charts for acceleration and velocity. So we already have the velocity sign chart, but now we need the acceleration. So go ahead and get the acceleration one, stack them on top of each other, and then make your conclusions. Okay, so once again, let's take a look at our work and compare. You first should have found your acceleration function, okay, which is 6t minus 22. Set that equal to 0 and solve for t to get your critical value. So t is 22/6, which of course is the same as 11/3. All right, then I went ahead and set up my acceleration sign chart, starting at 0, having an arrow to the right, and putting 11/3 in the middle. Okay, so when I plugged in a number between 0 and 11/3, I got a negative, and I plugged it in, of course, to the acceleration function. Okay, and I got a negative value. When I plugged in a number bigger than 11/3, I get a positive outcome, so I marked that with a positive. Okay, I stacked my v of t function underneath, okay, and I lined it up, so my zeros are lined up. 4/3 falls before 11/3, and so I put that here, then your 11/3, then 6, and then of course the arrow. All right, so I grabbed my v of t markings and properly put those in. And so then I could compare, and in order to be speeding up, remember, a of t and v of t should have the same signs, and that happened. They were both negative between 4/3 and 11/3, and both positive from 6 to infinity. They were slowing down when they have opposite or different signs, and so that's between 0 and 4/3, and between 11/3 and 6. Okay, so please make sure that you have your conclusions. Once again, you need all of these pieces. Tell me what's happening, speeding up. Tell me the intervals of time when that's happening, and the conclusion. And I was a little bit sloppy on number 1 because I didn't say what was the same signs. So you should say a of t and v of t have the same signs. A of t and v of t have different signs. All right, so let's move on to the next example. Okay, so this third example says a particle travels along the y-axis, so we're moving on the y-axis, according to the position function y of t equals 2t cubed minus 21t squared plus 60t plus 3, where t is in seconds. And notice that they're using y of t instead of x of t. That's all right. They're just using that because we are moving on the y-axis and they want to draw attention to that. So as we move on the y-axis, of course, we're going to move up and down rather than left and right. All right, so keep that in mind as we move through the problem. At what times is the particle at rest? Okay, we've answered this a couple of times. Hopefully you should right away know that you're talking about movement and movement not moving actually, and so that would be velocity, and when velocity is equal to 0. So we're looking for when the velocity function is equal to 0, which means we need the derivative of the position function. So that would be 6t squared minus 42t plus 60. Okay, set that equal to 0. Looks like I can factor out a 6, so I'm left with 6t squared minus 7t plus 10. All right, so I should be able to factor that, and I get t minus 5 and t minus 2. And so t equals 5 and t equals 2. Remember, of course, that these constants that you factor out, you could go ahead and set them equal to 0, but they will not equal 0, so they're just ignored or they're just cut off. All right, so our two answers here then are time is 5 and time is 2, and that's when the particle is at rest, and the reason why is because the velocity is 0 at those times. Okay, this next one is worded a little bit differently. It says it's the particle moving up, down, or neither at time of 1. Give reason for your answer. Okay, so again, draw attention to what they're asking. Movement, moving up, down, or neither. Well, we know it's not neither because we've already talked about when it's not moving, when it's at rest, and those were at times of 2 and 5. So now we just have to decide, is it moving up or down? And how would we decide that? Well, remember, we talked about if your particle is moving up, well, that happens because the velocity is positive at that time. If it's moving down, it's because the velocity is negative at that time. So we don't need to do an entire sign chart. We just need to find out what the velocity is, what the value of the velocity is when time is 1. So I'm going to go ahead and take my velocity function that I found from last time. Okay, now I'm going to go ahead and find that velocity at a time of 1. Okay, so that would be 6 times 1 squared is just 6, minus 42 times 1 is 42, plus 60. Now remember, I do not care what the actual numeric value of the velocity is at 1. All I care about is if it's going to be positive or negative. So if you just kind of look at this and see what are you going to get, a positive number or a negative number? Well, 6 and 60 add up to 66, minus 42 is definitely going to be a number greater than 0. So I can say that v of 1 is going to be greater than 0. Therefore, because the velocity is greater than 0 because it's positive, I can go ahead and say the particle is moving up. Okay, last question we're going to tackle tonight says find the speed of the particle when the acceleration equals 6. Okay, so I see that word speed, okay, and we've talked about that. That's the absolute value of the velocity. So that's something we should be able to find, okay? But then the next part tells us when, the time for which we're finding the speed, when the acceleration equals 6. Okay, so this is the part I need to start with. I need to first of all start and determine when does my acceleration equal 6. In order to do that, I need the acceleration function. Okay, so I'm going to grab that velocity function that I had the last couple parts, and I'm going to go ahead and take the derivative of that to get the acceleration function. Okay, so there's my velocity function. The derivative of that is going to give me my acceleration function, so 12t minus 42. Okay, and now I want to know specifically when the acceleration equals 6. So I'm going to set my acceleration equal to 6 and solve this equation. So that means I'm going to go ahead and add 42 over, so that would be 48 equals 12t. And so t here would be 4. All right, so now I know the when part, I know the t. Now go back to the problem. What does it want? It wants you to find the speed, which remember speed is the absolute value of velocity. So the speed when the time is 4. So now I need to grab this velocity function and do the absolute value of it. So absolute value of v of t just looks like absolute value of 6t squared minus 42t plus 60. And I'm going to go ahead and find that when the time is 4. So that would be the absolute value of 6 times 4 squared would be 16 minus 42 times 4 plus 60. Okay, so the absolute value of v of 4 is equal to 6 times 16. Well, that's 36, carry the 3, so 96 minus 42 times 4 is 168, and then plus 60. All right, so 96 plus 60 would be the easiest way for me to go. So 96 plus 60 is 156 minus 168. So remember, of course, this is the absolute value. That would give me an answer of negative 12 inside there. But since it's absolute value, I would have to say that the speed would be positive 12. And again, they didn't give me a unit of measure, so I'm just going to say the speed is 12. Okay, that's the end of today's lesson. I hope that some of you that are in physics, either currently or have taken physics, are able to start drawing some connections between the two classes. Certainly we were able to do that through related rates, and now again through these topics. So next class, we will be definitely spending some more time on this and practicing, and we will spend one more lesson on this as well. So thanks so much, and have a great night.